Hi, I'm Kia, and in this video I'm going to show you a sample physics word problem. So in this question, we have some givens and we want to solve for an unknown. So we're given the force acting on an object is given by a function of time, 2t squared plus 4t. So whenever a force on an object acting on an object is given by a function or an equation, we know that the function is changing over time. The mass of an object is also given is 5 kilograms, and v0, which is the initial velocity that the object is traveling, is 4 meters per second north. Because we know that velocity is a vector, which means it has a magnitude, which is 4, and a direction, which is north. Now, our objective is to find the final velocity, or vf, at t equals 4 seconds. So actually our answer should be like a finite value, not a function, because we want to evaluate the final velocity function at a given time. So what we're going to do is that I'm going to set up the equation we want to use. So the equation we want to use is the Newton's second law, which states that the net force acting on an object, which is also a vector, or the F, capital F, is equal to the mass of the object multiplied by the acceleration of an object. Acceleration is also a vector. It has a magnitude and a direction. So because I used the arrow to show it, that it travels at a given direction. Now, we know what is the net force, we know what is the mass, but the acceleration is unknown. How can we find the acceleration? So we know that acceleration in calculus is a derivative of velocity with respect to time, which means the change of the velocity with respect to time. So maybe we can write the acceleration in a different way. So let's see. If we can write the equation in a way that is capital F, so the force is equal to mass times, and I'm going to write acceleration as dv over dt. This is read as the derivative of velocity with respect to time, or the change of velocity with respect to time. Now we can actually plug in the values we know. So the force is a function, so 2t squared plus 4t is equal to 5 times dv over dt. Okay. Now we can see that we have a separable differential equation, a separable first order differential equation, which is quite easy to solve. So the first thing we're going to do is that we're going to separate the variables. How? I'm going to multiply both sides by dt. So in this case, these two cancels. And what we have left, I'm going to write it here, is 2t squared plus 4t dt is equal to 5 dv. Now, on both sides of the equation, we have a differential, dt and dv. How can we get rid of those differentials? We can get rid of this differential by integrating both sides. So I'm going to integrate the left-hand side from 0 to t, and I'm going to integrate the right-hand side, because it's the variable dv, the velocity, from the initial velocity v0 to v final. Okay. So what do we get? When we integrate this using the power rule, we get 2/3 of t cubed. So the final equation would be 2/3 of t cubed plus, and then integrating 4t is just 2t squared if you use the power rule. And we can see that when because we don't add a constant, because we're integrating over a limit bounds, 0 to t. And when we integrate over 0 to t, the result will be the same thing as just integrating and not plugging any values. Because for 0, it will be 0. And when plugging t, we get the same thing. Okay. Now, on the right-hand side, so this is equal to, on the right-hand side, when we integrate 5 into the variable v, we get actually 5v. And then we evaluate from v0 to v final. When we plug in v final, we get 5 times the final velocity, which is our unknown, which we want to find, and then minus 5 times the initial velocity. Okay, now we have a much easier equation, and now we can see that we have the initial velocity as 4 meters per second north. So actually we can write this equation as 2/3 t cubed plus 2t squared is equal to 5 times the final velocity, and then minus 5 times 4 is just 20. And then we want to solve for the final velocity, so we can add 20 to both sides. I'm going to divide both sides by 5, so we can get rid of the 5. So finally, we get the final velocity is equal to 2/3 divided by 5 is 2/15 t to the third power, and then plus 2/5 t squared, and we have a plus 20. 20 divided by 5 is plus 4. This is the equation we have. But we're not done, because we should find the final velocity at t equals 4. So our last step is just plugging in t equals 4. So final velocity is 2/15 times 4 to the third power. 4 to the third power is the same as 64. So we get 128/15. And then plus 4 to the second power is 16, plus 32/15. And then plus 4, which I'm going to write as 60/15. Now combining all the like terms, 128 plus 32, we get 160, and then plus 60, we get 220/15, which if we simplify, we get 44/3, which is approximately 40.667. So this is the final velocity in meter per second, and then north. So now we can see that we found our answer. First, we found the function in terms of the time, and then we plugged in 4. Thanks for watching. Please subscribe to my channel and watch my previous videos. Goodbye.